In this one, we're going to look at how to solve a literal equation. So what is a literal equation? A literal equation is an equation expressed in letters or variables. That's what it is. Most of the time, what this boils down to, this is when you have formulas and things like that, that you're then going to plug numbers into. Usually those refer to literal equations. And how do I solve a literal equation? When they ask you to solve a literal equation, they're going to pick one of the letters and then you want to get that to be equal to it. So how do I do that? How to solve literal equation for a single variable. Well, you simply just use the rules. Use the rules for solving linear equations. Okay? And you're just making that one variable the one you're going to get by itself. A lot of times when we did this one over here, and I'm going to pull it over so you can see it, in 3.2, we had only one letter in here. Okay? So we solved for that letter. Well, in a literal equation, there's more than one letter. And so we're going to solve for the one that is chosen for us. And to do that, even though there's other letters involved, we treat all other letters as if they were numbers. All other variables are unknowns, like they were numbers, as much as possible. Now remember, we got to be more careful when we do the combining like terms, because letters that are different are not like terms, and so we'd have to learn some techniques to help us do that, and I will show you hopefully some of those. So a very simple example of this is right here. So I'm going to give you P is 2L plus 2W. This is the perimeter of a rectangle formula. And I want you to solve for L. Now, currently it is solved for P. P equals, that means we're solved for P. To solve for L, I need to say L equals. So we're going to go through the process exactly as we did for solving linear equations, and we're going to get to the single L term over here. So because L is the variable I want to find, P and W are variables that I'm going to treat as if they were to move away from that L. So following the same guidelines, I don't have any parentheses, I don't have any fractions, I don't have anything I can combine, I don't have a variable on both sides, there's only one L here, okay? And so then I'm down here at this one, is there a constant? Well, technically no, there is no constant, this is not a constant, but because L is the variable I want to solve for, I'm going to treat that as if it was the constant. This is a term that's being added to the L term, so I'm going to add the opposite to both sides so that the L term becomes isolated. So the opposite of 2W is a negative 2W. And I line it up here because I'm going to add in columns. But when I put it over here, I don't put it under P. I offset it because P and W are not like terms. So then when I add this up, and you can do it in this fashion here, but I usually put the positive one first. This side over here is P minus 2W. And over here, I'll get 2L, and that drops out. And that's how that works. The last step over here is I have a number in front of L. So I'm going to multiply both sides by its reciprocal of the coefficient. The number in front of L is a 2. So this side is going to get multiplied by 1/2. And this side, so that's why I put the whole side in parentheses, will also get multiplied by 1/2. This side over here, the 2 and the 1/2 will reduce down to 1, and I get 1L. This one over here, I can write a couple of different ways. One is I can distribute which gives me 1/2 times P, and then half of 2 is 1, and I can use that right there. An alternate form of this one over here is just to multiply the whole top part by 1/2 and leave it in fraction form, and sometimes people will write, so an alternate way would be to write P minus 2W all over the 2. So this is another way you can express the same answer. See how I just took this whole quantity and just put it over the 2. This is usually happens when people say, I'm just going to divide by 2, which is okay. I have no problem if people want to just say divide by 2. You can do it that way too. Just know that I'm going to be showing in class the reciprocal multiplication of the reciprocal technique. So any questions or any doubts on that, just let me know, and I'll go over that with you. Another thing that I want to show you here on a very simple one also is here's the volume of a box or a rectangular prism. Length times width times height. This is, again, is a formula. And I want to solve this for H. Currently it's solved for V. Okay. So what's going on to H? We're multiplying by L and W. So since these are both doing exactly the same thing to H, I can treat them as one object kind of a thing. So in other words, this quantity is being multiplied to H. So I can remove those or eliminate that and make H equal by simply multiplying both sides by the reciprocal of that same quantity. So we get an LW times H, and I'm going to multiply it by 1 over LW. So all of that reduces out in one turn. I don't have to do each one individually, is what I'm pointing out. And that would be your solution right there. So why do we need to do all this? Okay, well, sometimes you need to manipulate things without numbers. That's the main reason. If I'm going to be plugging numbers into the formulas, then I usually plug the numbers in first and then solve the equation that way. But sometimes I need to manipulate things. And so this is why you need to know how to do this. Okay, we'll do more examples of this in class, but that's literal equation solving.